Hey, everybody. Welcome to Talking Serverless. My name is Paul Chin Jr. And here on Talking Serverless, each episode we bring on somebody who's doing something really cool in the serverless world, and we talk about it. It's pretty simple. But today I have the absolute honor to bring on somebody who is really good at just databases, really made a name for himself in the database world. And when you think about serverless, I think the future of serverless is figuring out the database solution. So without any further ado, I'm going to bring on Kirk Kirkconnell from Fauna DB.
Hey, y'all.
Everybody give him a round of applause. Awesome. Hey, Kirk, thanks for joining me today.
Thanks for having me.
We're going to chat about all kinds of things, mostly about database things, because I figure that's mostly where your expertise lies. And with that, can you go ahead and kind of introduce yourself to our audience, kind of what got you as somebody who's like an expert on Fauna and serverless databases?
Yeah, so I've been working on databases most of my career. I got started doing stuff. If I tell you, if I give everything, I'll give away my exact age. But I got started on. I mean, the old days of Oracle, SQL Server, MySQL. Obviously, all of those are still relevant. And working as a developer, working in operations to support them, even being a DBA for a while on Oracle. But then I pivoted probably about 12 years ago to NoSQL databases. Got my foot in the door on those and working with them as a doing developing on them and supporting them and architecting for them. And then I actually went to work for Couchbase. And I've worked for Couchbase, Redis, AWS, Memento, and now Fauna. So I've been in databases for most of my career.
That's super cool. Databases at first were very scary to me and daunting, and I didn't have a like a traditional degree. So when I first started using them, I just imagined it as like a hard disk, and I quickly found out that that is the wrong way to imagine things. I was imagining when somebody says put the image in the database, it's literally putting that file into a hard disk, but I quickly learned like the database is the data layer abstraction. It's where you make all of the wonderful pieces of state in your application really alive.
Well, yeah, I mean, that also depends. That depends on what database platform you're using. I mean, some of them are more, stripped down, for lack of a better term, than others, and some of them provide so many features. I mean, I've worked on some databases where we're using like 5% of the database functionality and features, and then we're like, why are we on this database still and paying $1 million a year? And okay, we should try and maybe re-architect this at some point. And then it totally depends on the platform and what you're trying to do with it.
Yeah, we'll probably get to that later about legacy decisions and migrating and doing changes over time. But first, why don't we kind of like set a level playing field? We're on Talking Serverless. Fauna is a serverless database. So we're gonna have to define like what makes a database really serverless.
Yeah, that's a great question.
I got my ideas. You might have yours, but
Oh, I definitely have ideas. I mean, have you seen like the blog post that I did with Kwaja Shams when I was at Memento about, faux serverless? I mean, there's a lot of services, not just data services, but other services that out there that claim to be serverless and so on and so forth. And I mean, so for mine for specifically for data, I have a sort of a modified list of what we originally came up with, and so but a lot of it's fairly similar, not all of it. And a lot of my reasoning is a little bit different than I sort of have changed some of my opinions over the years on some of these. But I guess the first one is, I mean, there's nothing to provision and there's nothing to manage. I don't want, when I go to do something with serverless, I want this stuff to be simple. I want to write my code. I want to write my application. I want to get it out the door as fast as possible. I don't want to have to worry about instances or servers or clusters or node types. This one's going to be read. This one's going to be read write. This one's going to be over there. I don't want to worry about that kind of stuff. Especially in the early parts, I don't want to have to architect that because I don't know necessarily Heck, I don't even know what my data model looks like yet. Sometimes, if I'm writing an application, so I need something that is going to be where I don't have to worry about that kind of stuff. And so the second part is zero capacity planning, and that sort of fits in a little bit with the first one. It's sort of a good progression there of zero capacity planning. And what does that mean? Is that not only do I don't want to have to deal with instances and stuff like that, but as I mean, there's always the traditional, oh, I scale up. And on some databases, I can scale down. Well, but I don't want that. I want to be able to scale. I just want the capacity to be there. And when I need it, I take it. And when I don't need it, I give it back. I'm just not using it. So that's kind of the sort of the second one that I really think about with a serverless database. And then the third one is ready with a single API call. I don't want to have to do anything where it spins up or there's a cold start. I'm there and I want to just throw a write or a read or a server-side function, and it takes care of it. It's immediately available. There's not any wait for any of that kind of stuff. The fourth one is usage-based pricing. And this is the one that sort of, for me, is a little bit, I've been going back and forth on this one. And I say that because of having dipped into startups more. Not that I've been in other startups as well, but I mean, is that if you go purely where you scale all the way to zero, that's fantastic for developers. But it's not fantastic for companies. They still need to keep the lights on. And if you want these companies to stick around, some of them have started putting in sort of that minimum barrier, which is, I said, I think that's fine as long as they have their pricing so that it's not outlandish. What I don't like is the ones where they want you to have, they try and force you into a minimum capacity. If it's part of the initial piece, fantastic. But once you get to a certain point, I do want that elastic. I want to be paying, if I'm only using this much, I'm only paying for this much. And that's kind of a key piece. And so, yeah, anyways, that's when sort of my opinion on that one's evolving slightly as I learn more about the actual business side of databases.
The economic side of serverless going down to zero is an interesting one because for compute makes sense. You don't always need compute, but persistent storage, you kind of always need persistent storage. Even like as you're testing, yeah, you'll probably have test databases that you don't need running all the time or something like that. But once you're using a database, I would imagine you would need it at least up and available all the time, right?
Right. Well,
So
I mean, it's back to that ready with a single API call. Yeah, I want that available. And so I might hit it, and I might hit it all of a sudden at 10,000 times a second. And then a little bit later, I'm hitting it at like 500. And so fine, whatever. But I need it available, and I need it replicated. I need it backed up. I need it this. I need it that. And I want it dependable. And I want that company to stick around for a long time because you like their product, and I want them to succeed so I don't have to migrate somewhere else.
exactly.
That's the other one.
Maybe I could ask you, along the lines of not needing to provision, not needing to worry about servers, what is the core primary primitive unit of database you would like to see or that are out there? Like, so if I'm thinking about databases and I want one, and then I say, okay, I'm going to define through some configuration, like give me a database. But then what are the other primitives that I should be thinking about in terms of building up capacity or capabilities? If it's not in cores, if it's not number of cores and megabytes of RAM, what is it?
I mean, that comes down to, a little bit of that, but also pricing. I mean, it comes down to read and write ops. I mean, is really what I get down to is how many of those am I using per second, and how many of those are available? I mean, on some serverless databases, you do have a little bit of capacity planning. DynamoDB, for example, it has, if you're in provision capacity mode, you need to say what your floor and your ceiling is, and if you look at, but if you do on the usage based, then there is no floor and ceiling to do that. So it just depends on the database, on the platform you're looking at. But again, you're getting back to how many reads and writes is what you're doing, because there's not memory to allocate. There's not, I need a faster CPU. I can't store all this in memory. That's not in a truly serverless database. Those aren't a thing. That's all handled on the back end for you. That's what you're paying for, is for the experts to handle all of that. Again, it's not about scaling up and scaling down. It's just, I need capacity. I don't need capacity. I just use it. I just use it. It's a utility. That's what I want. That's what I really want, is that it's a utility that I can. It's like flipping a light switch. I need lights on. Oh, I don't need lights on, and that's what I want.
The distribution, the regulation, all of the bandwidth, all of that is done behind the scenes, provided by the vendor.
Absolutely. Yep.
This is really interesting because if you think about traditional databases and the database conversation, it is never about that. It's always about, well, like, how big is this cluster? How many more clusters can we put together?
Am I scaling out? Am I scaling up? Scaling diagonally or multidimensionally? Yeah.
So maybe that would be for a serverless database, then a developer, an architect, what are the questions that they should be asking themselves in terms of developing that read-write architecture? Then, like, what should they be looking for? Like, say you're reading throughputs, and it's going to be read heavy, not very write heavy. It's like a catalog. Lots of places have to come and check this catalog to authenticate it against whatever they're checking against, right? Like inventory or something. What should an architect do kind of maybe in that case?
So I'll talk more about NoSQL databases, because that's what I know more of, and that's what I've done a ton of sizing for and data modeling. And so there's sort of three questions that I ask, usually, well, four really, actually, when it comes down to that. And because data modeling is extremely important in NoSQL databases. In relational databases, it's important too, but you have third normal form, and most people stick to third normal form in a relational database.
What did you just say? Third normal form?
Yeah, third normal form.
I am new to that term. Could you please enlighten me on that? Yeah.
That's a talk over a beer, dude. I
See. Okay.
that's how all the tables relate, and how you have associate tables, and you have lookup tables, and this. It's all the forms of how you do data modeling. I don't know that I can give you a crisp answer right this second, honestly.
That's totally fine. You know what? Every time I find a new Wikipedia hole to go down,
Oh God,
it's always a pretty good time. I can't complain. I just do it to myself. So, all right.
Like I said, data modeling is incredibly critical. And so when I think of data modeling with NoSQL, I try and plan out what are going to be my application's access patterns. And when I started asking for each one of those is, what data do I need? When do I need it? What's the frequency I need that? And what's it going to cost me to do it? And what I mean by that is that, so what data do I need? Okay, if I have us on screen, we say like an inventory program, well, what is going to be on screen for the user? What do I need to be able to do? And I need to go, okay, when I do that, I need this data, this data, this data, and this data, these pieces of data. Okay, when do I need that? Well, I need that on this screen, and this screen. But when I do this screen, I don't need this other piece of data. Okay, that's so fine. Well, how frequently am I going to be doing this? Is this something I'm going to be potentially doing 50,000 times a second or 5 times per second? And that really matters, because if it's something that's 50,000 times a second or 100,000 or whatever, well, there's usually a point in an application when you're accessing the database where, you know what, I really should optimize for that. And I want to put some extra effort into that part of the database so that performs really well. Whereas if it's going to be 5 times a second, well, I can be a bit looser with that. And then that plays into the fourth part of cost, because if it's something I'm doing 50,000 times a second and it's cost inefficient because I'm doing full table scans or full collection scans or whatever, I'm going to go, well, this database sucks because it's costing me too much money. Well, more likely you're using it potentially incorrectly. Your data model is off, and there's some optimizations that you should be looking at. At least that's been my experience with it. Like I said, I've been at Couchbase, Redis, Amazon, Memento, and Fauna. 5 different companies that I've been working on this. And I also, when I first started doing NoSQL, I was working with not for, but with MongoDB. And so, it's usually about learning how to use the tool correctly. So again, you've got to get to, what data do I need? When do I need it? How frequently do I need it? And what's it going to cost me to do it? Because if it's something that's going to cost I mean, $50 a month for a small application, that might be okay. But if it's going to cost me $5,000 a month to do this, well, holy smokes, no. I got to figure something else out, or use a different database. I mean, that might not be the right database for me. Is the other thing is that you got to pick the right platform for the right reasons.
I do think that in most organizations and most developers, they'll come across more than one type of database for their systems, right? You'll have different databases to do different things for different workloads. And as they say, if you're brave enough, anything can be a database.
Doesn't mean just because you can doesn't mean you should.
So I'm interested to hear about what it's like in your experience going from SQL to NoSQL and sort of taking NoSQL to the next level, right? Because
Yeah,
in my basic understanding of the history of databases, right? Like SQL came out and it was great because you put all the computation.
it still is great. That's the other key thing. It still is great. It's not.
There you go.
Anyway, sorry. Go ahead.
No, that's perfect. I was gonna say because like over time, the NoSQL came out, and I would say that the newer innovations are in this like NoSQL realm because it's a lot looser, I suppose. So tell me about your experience through that transition and what that's like. Go ahead and feel free to get super database nerdy. I think our audience would love that.
Yeah. So, I mean, I see databases. I don't know if anybody else sees it like this, but I kind of see databases as a Rubik's Cube. And I've always seen it as a tangible item that I can, well, it's something like that. I mean, it maybe starts out as a square, but I can turn it. There's different facets to it, but I can also spin it and make something different out of it. And so, with a relational database, in many cases, I can spin it and do this thing with it, but then I'm still locked into that form. I'm still have that polyhedron, that six-sided die of that, and I'm like I said, I can spin it a little ways and I can move it to different colors and whatnot, but that's fine. With NoSQL, I mean, you said about like, I mean, innovations and giving stuff up and whatever, but I see it as more about trade-offs. What do I need to trade off? What do I, you know what? I mean, there are some databases where I have to trade off consistency. But what do I get in return? I get, let's say, speed. I get the performance that I need. In some databases, that consistency is tunable. I can go for this one call. You know what? I need drag racing speed, and it's got to be fast, and I got to do it 100,000 times a second. And so, if I lose a few of those, because let's say I'm caching state or something, I don't know, that is not the end of the world for mine. Or they get a version of it that's 3 seconds behind, that's not the end of the world. But if I'm doing a monetary transaction, well, you know what it is? That's a problem. So I need that one consistent. Whereas in a relational database, you can't trade those off. Those it has to be consistent all the time, and you have to when you're writing everything. And so, but the other big thing is when you're designing for a relational database, in my opinion, you have to design it the way the database wants the data stored, not necessarily how your application is using it. And in a SQL database, I can now design it how my application is going to use that data. I can store it in a different way. I can now use denormalization. And in some databases like Fauna, I can use denormalization and normalization. So Fauna is a document relational. It sort of mixes the best of the two. But in a lot of them, I have it where I can now model my data differently and have it where I'm tuned to my access patterns. And therefore, I can change how I do things inside the database, how I flip that. And so now I'm not at a square. I have an icosahedron, a 20-sided die that I can now flip differently and spin differently and make different things out of it, depending on how I slice it, depending on how I do my indexing and querying and so on and so forth. And depending on what the query language that database has, I mean, whether it's limited or is it pretty robust. So that's kind of how I see it is that I want to be able to tailor it to my application. Now, not everyone needs that. That's the other key thing. I mean, you were saying, oh, look, I mean, SQL, it was really great. I mean, like I said, it is still really great, and it's ubiquitous. I mean, most people learn SQL at one point in their career. If not, I mean, if they're in comp sci, they learn it in classroom in college, and many times. But it's not right for everything, and that's okay. But I mean, I remember sitting in a conference for MongoDB a few years. I mean, this was 12 years ago. And the guy on stage is saying, well, why are you keep designing using these traditional databases? And someone from the crowd yells out, because they work. And and everyone's just kind of like, but the thing is they do. I mean, they do still work, and so there's room for all of these databases. It's just you got to pick the right one for the right use case.
Right. So, is there a? I guess help me clear the fog in my brain around when I think of serverless.
Yeah,
I always think of NoSQL, and I don't know why.
probably because there are more of them.
Yeah, but then you could have a serverless SQL relational database too, right? As long as the vendor kind of took care of everything.
To some degree. I mean, it depends. I mean, probably the closest is going to be like Aurora serverless, AWS Aurora serverless. But even that, I mean, and to my litmus test, it doesn't exactly fit in there because you still have to pick node types. They've done away with, I think if I recall correctly, they've done away with picking the instance types, if I remember correctly, or you have to do it on an existing cluster.
I think it still doesn't go to 0 either.
No, yeah, it does not. It doesn't go to 0, I think, if I remember correctly. Yeah.
Yeah.
But if you notice, all of that stuff's in the fine print. That's all the like all that a lot of that kind of stuff. So I mean, there's been a lot of marketing hype around serverless in the past couple of years, which I'm sure you've seen. So yeah, well, no. I mean, like in the sense of people going, "Hey, we have a serverless product," and they have made it an existing product and then slapped on it and says, "Oh, now it's serverless," and sort of, but I think what you're seeing there with because of NoSQL is there's more of them that are NoSQL because they're newer and they don't have the same. They can make They can make trade-offs. They can make trade-offs in the architecture, whereas everyone expects a relational database to always be consistent 100% of the time and do these certain things. So a lot of those things, not all of them, but a lot of them don't play necessarily well with serverless. It's not, you do have to have some capacity planning. You do have to have some provisioning. Getting that with that single API call with no cold start and no planned downtime, that's difficult. And if you don't design for that, then you're not going to have those. A lot of these databases they're not, I mean, whether it's Postgres or Oracle or MySQL or whatever, they're not originally designed for that. So, yeah.
Interesting. So if I'm looking at a serverless database and I'm like, okay, what I know more of is Dynamo. I've worked with Dynamo for most of my career, and I just sort of got used to it. And whenever I'm working on a SQL system, I always have to actually end up learning like the ORM, like the middle layer to actually do anything. With serverless databases and maybe with Fauna's offering, like how does that middle layer work, like the API calls and stuff? Is there an SDK? How do people can they write? I'm assuming they can write whatever language they want.
Yeah.
How does that interface work?
So for Fauna, it's an HTTP based API. I mean, so you could use any language. And so I'll give you an example. One of the things I'm running right now is some Arduino code because I want to be able to monitor humidity and temperature and a couple things in the freezers that I have in my cellar, and also in the area around inside the cellar. And I want to be able to report that on a minute by minute basis and then do some calculations off of that. Anyways, Fauna does not have a C++ client library, but I just easily just throw an HTTP call because it's right in there in the Arduino UI. And now I'm writing to Fauna and I can call server side functions. I can do everything that I need to do in Fauna. I can do that. So the client libraries in Fauna are actually just language specific wrappers around that HTTP API. It just has it has the niceties of, I mean, Go, Java, JavaScript, Python, and so forth that you would expect in a client driver, but under the hood, it's talking HTTP API. So if you want to do that from Erlang, then awesome, go for it. As long as you can hit with HTTPS using TLS 1.2 or higher, you're golden. Is that. And so, but the beauty of that is that you can now do it from like edge functions. Like, so if you're in like, I mean, Vercel or Cloudflare workers or something like that, you can have super lightweight serverless functions that don't have a client library. And they're like really, there's like a couple of kilobytes function, and they are running and hitting a full-fledged enterprise class database. And so that's a really nice feature, being able to do that. And there's a couple of databases that do that too, but then they don't have some of the other features that Fauna does.
So you're getting rid of the like the connection pooling, the need for connection pools, like the data accelerator pipeline or whatever, like all these little caches that get built around other databases in order for the application to not overwhelm the endpoint.
Yeah.
Are there any networking latency issues of it being always HTTP that comes up in real world use cases?
Haven't seen that. I mean, one of the beauties of what Fauna has is that it's a 3DNS. So when you hit, I mean, db.fauna.com, it actually takes you to whatever the closest endpoint is. So it's not like it's going to be an endpoint in California when you're on the East Coast. It's going to be an East Coast US one. If you're in Europe, it's going to hit a European one. If your database is hosted in a region group that has Europe as part of it, so it's not going to try and send you across the pond if it can help that. I mean, obviously, if something's down, then it will. But I mean, but on a regular steady state, everything stays as close as possible, so you get the best latency, and all of your reads and writes go to that local one as well. And any of the consistency, I mean, all the writes and everything and the reads and writes are all strongly consistent in Fauna, but Fauna takes care of all of that. Your client application knows none of that, of what's going on. It talks to that endpoint. That endpoint talks to directs you to the local as close as possible, and everything happens behind the scenes for you.
Cool. So on top of being available, I guess it's a fully distributed system. You're not choosing regions. Is the user choosing regions?
So you're not picking specific regions. You're picking what we call region groups. So let's say you want to have your application only in the EU. You want to stick with GDPR, and your application's only going to be there. You can pick that as your region group, and it will be stored in 3 regions that are located in the EU. You can do that same thing for the United States, where it'll be in 3 specific regions in the United States, or you can have a hybrid where it'll be, at least for now, where you can have it replicas in the United States and 1 replica in EU. Now then, if you have what we call virtual private fauna, where it's a dedicated cluster. I mean, we still manage everything. It's still exactly the same thing, except then you can say what regions you want, because it's a dedicated cluster to you and your organization. Then if you want that, that actually can span clouds. You can have it in where parts in Azure, parts in GCP, and parts in AWS if you have virtual private fauna.
I see. So that would be like your mega enterprise scale that wants a full control over the like the geo IPs and stuff like that. Like they need that kind of stuff.
Yep, and they want everything to be strongly consistent between all of them. That's the other key piece. I mean, replication is. I mean, I was getting ready to say replication is easy, but that's not true. But replication where it's strongly consistent, that's really hard, and that's what one of Fauna's key features. It's not the only one, but I mean, that's one of its key features, is that if you're writing between all of those regions, regardless of where they're at, everything is always strongly consistent.
Okay, all right. Man, I'm learning so much from you today, Kirk. Thank you so much for being here. So I'm going to go back through. You said when you're designing those access patterns, it's like, how you're going to use it, how long it's going to take.
What data do I need? When am I going to need it? How frequent do I need it? And what's it going to cost, performance and physical dollar-wise, to do it?
Yes. So I wanted to come back to the cost thing, because with serverless databases and these databases as a service, more or less, right? You get some configuration, but you're not going to get all the ones that somebody may be used to from a more like deeper, expansive, like base database, right?
Right. There's not as many knobs and switches to turn.
But what levers and switches and stuff do they have? Like, what are the ones that really make a difference, and the ones that maybe people wouldn't know about that are possible?
So from my experience on all these different ones, the hands down, the number one thing that is the dial that makes this, I mean, that changes spending. It's one of those things where people, they kind of know it, but they don't want to worry about it because it can be difficult, is your data modeling. Your data modeling and your queries. I mean, because if you get that wrong and you're scanning too much data, or oh, you know what, I'm going to put in 10 indexes in this, but this one index I only use, I mean, like once a month. Well, it costs me to keep that index and keep it so it's got the data all the time. I mean, if it's it's a copy of some of the data from the table, I'm paying storage on that. I'm paying operations on it because I have to keep that up to date. I have to keep it consistent. I mean, even if it's eventually consistent, I still have to, every write to the collection or the table still has to go to that index to populate that index. And so one of the biggest ones, I mean, like my favorite one is that, okay, like I was saying that with the, oh, it's an index, but I only query it for a report once a month. Well, maybe you should look at what does it take to do a full table or full collection scan once a month, because it's possible it could cost $30 to do that one report per month. And you're thinking $30, holy crap. But it costs $60 to keep that index up to date. And that index could apply back pressure on the base table or base collection, depending on the database. That could cause problems as well. And so it's those kinds of things. I mean, those are sort of a smaller example, but it also, again, you get back to those 4 questions of what do I need? The ones that are highly frequent, like I was talking about earlier, those ones need to be super optimized. And so you might make concessions in your data model, and you might do something that you would never do in a relational database, which is replicate data. So I'll give you an example. So I was actually working on a document just the other day for about migrating from Postgres to Fauna. And one of the examples was talking about, it's like a film and actors. And well, what do you put it? Do you put the actors inside of the film document, or do you have them so that they're in their own collection, in their own documents, and you relate them? And the answer, as any senior IT person says, is it depends. And one of them is you can do it where it's relational, and you can traverse that relationship in Fauna and get that other document. Okay, give me all of all the actors for the movie Gone with the Wind. Fantastic. Well, but when I'm on screen, and again, this gets back to that second question, when do I need this? When I present the films on screen, let's say I'm only presenting names. Well, maybe I want to embed the name into the film and have the relationship to that other document if I need more information, if I want to have a link that's more information about that actor. But on screen, I'm presenting just the person's name because that's what someone wants initially. That's what I'm presenting all of the actors. So I embed the name, and names don't change that often. They can, but they don't often. And so it makes it so I don't have to keep reading. I don't have to do that other read, traverse that relationship, and get that other read to that other document, because I'm reading the one document. It's less than 1K, and I'm good to go. And so it's those kinds of things that it's foreign thinking if you're coming from a relational database. Because you just would never do that. You would do where you have like an association table where I have multiple films, multiple actors. I have a many-to-many relationship. I have a table in the middle, and I would have the table has the ID of the film and the ID of the actor, and I would join all of that. There's a price to be paid for that join. And so some of this stuff, it makes sense to pre-join. If I'm going to be doing, people look at films all the time. So if that's one of your main access patterns, optimize for it. Absolutely.
Yeah.
That kind of stuff it sounds difficult, but once you actually start thinking about your access patterns, that's where you have most of your knobs. Now, the other big thing in that, I mean, I just to stay on this for a second, is you have to be able to migrate, because that's one of the big things of, well, I don't know what my access patterns are all the time at the beginning. I don't know what I'm going to do. Like, so I'll give you a perfect example. I was writing the code for that Arduino app, and I was like, okay, I know I need to send, I have sensor data. That's one collection. And I have, okay, I'm going to have a user now. Okay, so what's the relationship there? And so, well, crap, I already have all this data that's this and this. So I need to be able to modify my data model. Well, in some databases, that's really tough to be able to migrate from an old data model to a new data model. And I need it so that that is really simplified. And do I enforce that data model like I could in a relational database? And so that's the kind of thing where I need it so that as my stuff of my application evolves, as I write new things, or the product manager says, "Hey, I need this really cool feature," well, I need to be able to change my data model. And if it's difficult to change, like, I mean, I'm not going to name names, but there's one specific database I have in mind. But if it's difficult to change, then I'm less likely to make that change. I'm more likely to do something that's going to cost more money, because I don't want to make that, and I don't want to do a data migration. I don't want to have to write all the code to do the ETL to do a data migration. So I need something that's going to be super simple in order to actually make these kind of changes, because applications change. That's just life. I don't always know my access patterns. And a month later, I'm in a development. I'm like, holy crap, I need this now. I need the data to relate to the person, not the device or whatever. I mean, so that kind of stuff.
What is your general take on migration patterns, and what are the tools that devs and architects can use so that as they look forward toward a workflow, I guess I'm asking, right? Because you're going to do some discovery, you're going to figure out requirements, you're going to put it out, you're going to try it, it'll work for a little while, and then as requirements change, what is my workflow as a developer to adjust that data model? I guess it's easier in NoSQL, right?
Well, for the most part, yes. I haven't done it as much in relational databases lately. It used to be a real pain. My favorite war story around that is I was working on a PeopleSoft database, and I was upgrading the database, and I didn't add the error handling in for the data migration because it was doing a alter by table rename, and I dropped the production payroll table for 150,000 employee company.
Little Bobby drop tables. He came out.
Exactly. And so, well, I forgot, because you had to manually put the error handling in each one, and I forgot one of them. So migrations can be really difficult if they're done manually. I mean, there are tools and they're usually pretty database specific. So I don't know all of them. I mean, and in Fauna, we actually built it into the product. It's actually to do a migration and all the database. And so you don't actually have to write code, like write a separate app to do a migration in Fauna. So we have Fauna schema language, which defines all your schema. And then you can say, okay, I'm changing this, I'm adding this, I'm dropping this, and here's how to do the migration. And Fauna takes care of it and does it inside the database. So you're not dragging data to and from, like, let's say an EC2 instance or whatever. It takes care of all of that inside the database. And if you're, one of the really cool features is that it does it in a lazy way. The schema changes immediately, but it starts changing the every document that you wanted to in the background. And then if, let's say, a read or something, or write comes in and that document hasn't been changed yet, it will immediately change it and then do your operation that you just asked for. So it actually will do it on the fly.
Yeah, like in real time.
Yeah.
So your actual in-use database doesn't go down?
Correct. Yeah.
Like there's like no downtime migration? Is that
Zero downtime migration? That's exactly what we call it.
Huh.
Because the database is aware the migration is going on. That's the really cool piece. It knows that there's a migration, and therefore, wait a second, this one hasn't been migrated. I'm going to change it real fast, and then I'm going to do the read and write operations.
That's very cool. I didn't know that. I haven't played with Fauna in a really long time.
It's come a long way in the past few years.
Oh, I think the last time I used it was definitely about 4 years ago.
Oh yeah, and the query language is vastly different now. It's based off of TypeScript. So if you've written any kind of JavaScript or TypeScript, you'll be like, oh yeah, method chaining.
Oh, nice.
So now you can actually get front-end developers to write back-end code because they can write JavaScript essentially.
Does that mean we can finally get rid of GraphQL? That's a hot take.
Yes.
But I I know lots of people love GraphQL. I never really got into it. But what you're describing sounds like I don't need it and like that kind of decoupling anymore.
Yes. And you don't need an ORM anymore either. You won't need an ORM. Like I said,
You know, was it the newest node is doing a TypeScript compilation behind a flag, I think.
yeah.
So it's all heading towards more of a less of a standard, right? People are getting more comfortable with this type of tooling. I'm gonna have Node. I can write my TypeScript. I know the is it a Fauna query language or is it
Mhm. Yeah.
okay? So it's a Fauna query, right? Fauna query language based on TypeScript. HTTP calls back and forth.
Yep.
That's very cool. So how does Fauna do like production, development, staging environments?
So, I mean, you can have that inside of the same one because you can have as many, depending on your subscription level, you can have how many databases you want. So you can have it where it's set. What's really cool is if you're using the Fauna schema language, like I mentioned before, to define what your schema is, you can actually take that and then just say, okay, now I'm going to go to this other database and take that whole schema, every structure, every index, every function, every role, and just populate that other database. You run it with the Fauna CLI, and now poof, that database has had it. And if you have the migrate, you test the migration in your development, and then now you can do the migration in production for real. So you can do it, have extra as many databases as you want inside of the inside of Fauna itself.
Okay,
And there's even parent-child databases as well. So for organization purposes and for like multi-tenancy.
that's very cool. Now, is the security for Fauna similar to like DynamoDB, where you can like lock down to row access only kind of permissions for multi-tenancy type of situations, right?
You can get down to where it's attribute based. You can say you can have access to this attribute. And what's really cool is that I can base the access off of data that's inside the database or inside of a collection. I can say what let's see what is Paul's work hours and what's the current time right now, and if it's between 9 a.m. and 5 p.m. on the East Coast, he has access to this data. If it's outside of those hours, no access.
Huh.
And it's dynamic. So it's not like it has to change something on a daily basis. It's just automatically looking every call that goes in. It says, do I have access? It runs that and looks at that information. You could have it where is this person a manager, and they can immediately see their direct reports. But let's say they get promoted and they now have new direct reports. It automatically changes if you have set it up correctly, set up the permissions correctly, so that
Hmm.
they're still a manager, but they have different direct reports, and now it can only see their new direct reports, not the old ones anymore. Anyways, I mean, you can, like I said, you can base it off of data inside the database.
So I think I've again learned a lot, thought about a lot. I need to go play with Fauna again. Um, I need to come up with a cool Nicolas Cage type project where I can throw some Fauna in there. But maybe I wanted to get your take on what would Fauna or a serverless NoSQL database not be good at, because I'm thinking of other like those big like BigQuery and like what do they call them, columnar databases or whatever. What is your uh, what is your opinion on that? Right, like what can't I do?
Yeah, well, I mean, most NoSQL databases are operational databases. I mean, it's OLTP. And so if you're getting into heavy queries where I have big questions about big data. A lot of NoSQL databases are not necessarily. Now, some of them have added services onto them, and they can do like a query engine, or I mean, not query engine, but a search engine, and other features, and that's all fine and good. But that's essentially adding another service, and you could do that by. I'm like when I was at DynamoDB, we always had it where we used streams and you pushed everything to S3, and then you would use Athena to hit on that same data or push it over to OpenSearch, something like that. I think they just did native OpenSearch integration not long ago for for DynamoDB. And in Fauna, we have event streaming as well, and you would push that data over to something else that is more suited for that analytic stuff. So that's a good example. Another one is always a consideration, in my opinion, is what does your development team have experience at? You need to have a compelling reason to if you're going to switch and you're more familiar, the whole team's more familiar with a relational database. You need to have a compelling reason. It can't just be, ooh, shiny box. It can't be that. That can't be the reason you do it. It has to be where, you know what, we have some trade-offs to make, and I've hit a wall, or I foresee I'm going to hit a wall in this database with how it's going to scale, or it's going to get really expensive. I mean, when I mentioned before about learning about MongoDB and Couchbase very early on, those are the two first databases, NoSQL databases that I played with. We were, like I said, on Oracle. We were spending $1 million a year on Oracle licenses and another 500,000 to 700,000 on storage. And it was slowest performance. We used maybe 5 to 10% of the functionality. We went to MongoDB at the time, and again, things have changed dramatically in MongoDB since, I said 12 years ago, but it was $80,000 to do that. Now, not everything's cheaper. Prices have changed. Inflation's happened. But my point is that sometimes that changes. That can absolutely be a factor. Again, it can't be the only factor. And you can't dismiss what is it that your people know. If they're, and what's your timeline? If look at the trade-offs and you go, okay, I can design this around my access patterns, and this is a direction I want to know. I want to be able to have this as a tool in our tool belt. This database is a tool in our tool belt for later on. Then it's time to invest that time. But if you don't have that kind of time, you're like, you know what, this thing has to be out by the end of the month. Then that might not be the time where you make that jump. It just depends. But I've worked with a lot of people where they're like, it's shiny, it's great, it's fantastic. Okay, but you got to invest it. You got to learn how to use that tool. Otherwise, you end up people, like I said way earlier, is, oh, this database sucks. NoSQL sucks. Well, it's because you're using it wrong, most likely. Not always, but most likely you're using it incorrectly. You're not doing the data modeling correctly.
A lot could be said for just Lambda functions. People, they use them incorrectly, in my opinion, using them for things that they're not really supposed to be doing. And then you get mad at the system and you're like, oh, you got to look deeper at its inherent qualities, right? And so when you're looking at a database, what it should do for you, you also have to realize like the people work behind it. You're not just going to immediately pick up a tutorial and have a production database, at the end of the weekend.
Right. And get all the benefits of that new database.
Sure.
Yeah. Well, my other, I heard a word the other day, I thought it was fantastic for serverless, is talking about lambda-lithic functions.
Lambda-lits, yeah.
And it's like lambda-lithic. I'm like, that is genius. I have seen so many times where someone just takes it, I'm going to take this whole thing and just shove it into Lambda. Okay.
Yeah, with Lambda-lits, you basically like rebuild API gateway inside a Lambda, and and you're just hoping to God it finishes connecting through 9 different hops.
And maybe you lift and shift and do that, and then you optimize later. That's fine, but plan on optimizing.
Yeah. Okay. So, what do you think the future or the upcoming really cool things to look forward to in terms of maybe FaunaDB or just NoSQL databases in general? Like, where are we headed now that we've got some of these really nice, like that like feed forward migration thing is a really cool idea. I definitely want to play with that. What other things are on the horizon that you can talk about?
I can't be Fauna specific, but I'll say in general, the thing that excites me the most of coming with databases, and it's not unique to NoSQL, and it's going to sound cliche initially, but I'll explain it. I'll explain what I mean, is what's the intersection of databases and AI? Everything is, AI, it's the new shiny box. But I think it's different than what you see with generative AI and everyone talking about with ChatGPT is, and I don't think we've seen what the real intersection is here, is like I was talking before about being able to take that polyhedron and twist it and do different things with it. Well, I think AI, once you actually have it and doing some things in the database, it's going to be about, I have this store of really valuable stuff. What other things can I derive from this? What is the other what are the other ways that I can use this exact data and do more with it and have it where it's automated? I think that to me is probably the most exciting piece. And I've seen a couple of glimpses and a couple of products of it, but I think we're still a little bit out, and I think people are still stuck on the whole generative AI thing, and which is fine. I mean, but
There's other types of AI that are still yet to come. Right.
right, yeah. I mean, when you're getting into the machine learning piece, and actually, like I said, the real, I mean, deep learning on other data. What else could I do with this? And I think that's the thing that most people are not able to wrap their head around yet. And it's going to be a tool or a piece of functionality or something like that that makes it so that now all of a sudden I can not just twist the polyhedron, I can crack it open, and now it's this like origami piece that I can unfold, and now it goes from a bird to a beautiful chrysanthemum.
So, like in the same way where I feel like warehouses of physical goods can be stored for humans to go up and down or machines to deal with. And the systems created by machines for machines to deal with itself just look gnarly because the machine always knows where something is, whereas a human has to live through an experiential index in order to find something, right? And where AI can really take that level of, I guess, state management, right? Like, because that's what it's really doing. It's representing state in these new higher dimensions.
For now, I mean,
Yeah.
I mean, it's funny when I talk to people about stuff with vector indexes and vector databases, most people still don't know how they work. They still don't understand how the data is actually, how is it positioned in the database. They're thinking about it in the terms of a two-dimensional table when it's actually a multi-dimensional.
Yeah,
I mean, it's where a picture can exist in 300 different places at once. You're getting into quantum positioning.
so on top of your Rubik's Cube analogy, there exists a hypercube, which is a four-dimensional Rubik's Cube, and people can hypercube, and you use a piece of software that flattens four dimensions to three, and you manipulate that space in order to solve it, right? And it's really cool to think about the future where it's not just generative AI doing database stuff. I'm not talking to a database chatbot. The database itself has prescience about the state of itself, you know. So that's really cool. That's really awesome.
Yeah.
Now you got me going. Now you got me thinking about all kinds of big brain ideas. And it's the time of the show where I have to ask you the most important questions, the hardest hitting facts. And since we are talking about data modeling, I've always thought about whether or not gushers are a type of dumpling.
Oof. I mean, we're talking the candy, right?
Yeah, the candy gusher. Yeah. Yeah. Is it a type of dumpling?
It looks like a dumpling. It talks like a dumpling, but I don't think so. I mean, I've eaten a lot of dumplings all over the world, from Shanghai to Argentina to, I mean, in places in Europe. And I don't know. I always think of dumplings as something that's usually hot and in like part of a soup or something like that. I mean,
Yeah, it's very kind of it's got more noodle or dough.
right, right.
So if you were data modeling is dumpling or not, right?
I would say no, it is not a dumpling.
Okay.
My son asked me the other day, is a hot dog a sandwich?
Yes.
Get back to me on that. But I would say dumpling. I would say dumpling. No,
Okay. How about cereal is a soup? Like Fruit Loops. A bowl of Fruit Loops is a soup.
it would be kind of like what gazpacho's cold, right? So
There are cold soups.
yeah, there are cold soups. So yeah, I could see that. I could see where cereal is a soup.
All right, cereal is a soup. There we go.
Or maybe it might even be a stew because it's got chunky bits in it.
Oh, so yeah, the viscosity of the liquid possibly could adjust.
Well, the stuff in it, I mean, like a stew usually has, like, let's say you have a hearty stew where it's got vegetables like chunks of potatoes and carrots and
I would still say that soup is a higher level classification than stew, right? Like stew is a type of soup.
I could see that. My wife sometimes calls them a stoop.
All right, final one. Are you ready?
I am.
Are donuts bagels?
No, because bagels are boiled. And, well, but donuts are boiled in oil, not water.
That's right.
Oof, that's a tough one.
So are donuts bagels? Like if again, you're the DBA, you're the data modeler, is bagel function comes up.
I'm gonna go like a vector index and tell you that they have things in common. I mean, they have where they're both round. They both have a hole in the center. They both are, yeah. I mean, they have different toppings though, and then one of them is sweet. One of them is more sweet, and the other one is usually more savory.
But there are cinnamon raisin bagels that are sweet bagels.
That is true. You're right, especially with peanut butter in it.
Yeah.
I don't know that I'm gonna have to contemplate that one.
Wow. All right. I got you on that one.
Yeah, I don't have an immediate answer on that one.
Very, very cool.
My initial answer is no, but I need to contemplate it.
Thanks so much, Kirk, for playing data type categorization on foods. And with that, I think before we close up the show, I wanted to give you a chance to shout out things that you're working on. Where can people find you? What should they know about you?
Yeah, so you can find me on LinkedIn. It's just Kirk Kirkconnell. You can find me on X. You could find me on Discord. We have the Fauna Discord. And you can, where else could you? Oh, and on GitHub. You can find me as NoSQL Know How on GitHub. NoSQL NoSQL Know How and HOW. So NoSQL Know How.
Love that. Love that handle. Love that. That's so cool. All right. Well, thanks everybody for joining us today. I'm really happy we got Kirk on to talk about all things serverless databases. And I got to stump him with whether or not bagels are donuts or donuts are bagels. And with that, this wraps up this episode of Talking Serverless, presented proudly by Serverless Guru, your guide to cloud nirvana. Like, it's going to be great. If you have any questions about operating serverlessly in AWS cloud, give us a shout. My name is Paul Chin Jr., and thank you all so much. If you've liked this show, please leave a comment down below, hit the subscribe button, smash the likes, do all the socials interaction, and we will see you next time.